We have a MacBook Pro and it's coming in for no power. This is coming from another repair shop. So most likely they have done pre-assessment to the device. So we're not sure what we are going to find. So in terms of the charger to use for 13 inches, a 61 watts will work 100%, not 35 watts. You want to use a 65 watts, 61 or 87 or 96 or the 140, that will work 100%. So this is A228 A2289, which is a T2 device. It's a 28. It's an Intel device and it's a 2020, the two ports version of the 2020. So you see that it looks very similar to your M1, but it's not M1. Obviously, you can tell from the keyboard. Also, the keyboard that is not M1. If it was an M1, you see the global sign there. See that you will also find it here, but it is Intel, not an M1. But then if you put this side by side with an M1 MacBook Pro, it's going to look exactly the same thing, because physically they look exactly the same. But this is the Intel 2020 and it's coming in for no power. As usual, we are not going to plug power to it, because we don't know what state the device is in. So what we are going to do is we are going to pop the back cover out to see exactly what is it that we are dealing with. So we are using a P5 screwdriver to take out the back cover. And I also emphasize that you try as much as you can to protect the screwdriver from scratching the device. Okay, first thing we're going to do is okay, actually I see what the problem is here. So this is damaged by most likely a device, an external connection. So you see that the CD3217 is completely burnt out. So either from a charger or from whatever was connected to the device. So that is burnt out. So definitely that is going to be where our problem lies. So what we are going to do is seeing that we don't have to, so we just and then generally also the device looks clean. It also doesn't seem like the device was has already been opened. So most likely that it's going to be our only problem. That's the CD3217, which is the charging port controller IC. So that is responsible for managing the 20 volt, which is required for the device to work to function. So if you have a faulty charger connected to it or anything through the port, that is most likely what has happened. So after this repair is done, we are definitely going to inform the client to make sure that whatever it is, if it is whatever it is that they connected to the device before the incident, they should not connect it back to the device. And so we are going to check both. So sometimes the damage will happen on both. Since it has two ports, each CD3217 is going to be in charge of each port. So we are also going to check the other CD3217, because sometimes you find a situation where one of the CD3217 or 15 is it's damaged, and the person then just go ahead to connect the charger to the other port, which will also do the damage to the other port. Do you have it, or you have on your desk? On your desk. Small. Okay, so screw that out. The next thing we're going to do is to disconnect the cables. Okay, because you have an easy opening from this side, it will be easier to take the board out from this side, and you'll be very careful not to rip any of the cables. So usually I do not remove the DC jack, but because of this damage that we have here, we are going to take the DC jack out just to be sure that the DC jack itself is not being compromised. So I'm not sure if you guys can see that, but this is jack itself. So we have bridging cable lines here. So we are going to replace the DC jack as well after the repair is complete. Okay. Remember to put this back in. Remember to put it back on. Okay, so now that the board is out, let's check the other side of the board. So we are gonna check that. We use our multimeter to see if that is also affected. We're gonna switch it to diode mode. Okay, so let's check the components around it to see if we have a short. This is going to be on our ground, and then this we use. So here, what do we have? 1.80. That's about what we're expecting, and then this one 0.5. That's fine, and the other one 0.5. Then here. Okay, yeah, that's fine. That doesn't seem to be a problem. So the next thing we're going to do is we're going to remove that, and hopefully only that it's our problem. So let's get another one, a replacement. So we are going to we're going to take it from an M1 board, a MacBook Air. So this is CD3217B2, and this is CD3217, yeah, most likely B2 as well. Anyway, we are going to be using taking one from a MacBook Air, and while you're doing this the replacement, we are very much aware of the orientation. So you see the round dot here. You see that? I'm not sure if you can see that. That symbolizes your pin 1. So wherever you find that, that is where your pin 1 is going to be. So for example, you see here, now that's going to be our pin 1. So you have to orient it accordingly. You can also determine your pin 1 from your board view, but in this case, but usually components tend to have a dot, or to indicate where your pin 1. It's, for example, if you look at this backlight chip, for example, we have a small dot here. I don't know if you can see that. Yeah, so that is an indication of your pin 1. Okay, so let's take this out. Now these boards, they are very flexible. They're not that strong. So especially in this section of the board, you have to be very careful not to apply too much heat. Otherwise, the board is going to bubble up. So be very careful. And just beside it also is our SSD NAND chip. So we also make sure not to damage that. Usually because it's burnt out, also you might okay, so you might have a difficulty removing it, but good thing is it wasn't so difficult to remove. So there are two ways we can do this. We can just leave it as it is, and do a direct transfer, or we can remove the old solder, and then but it saves time to just do a direct transfer. If it doesn't work the way we want it, then we can always redo it. Okay, so that's out. So remember the orientation, it's going to be, let's see, I have to orient it like this, correct? Okay. Okay, so we hope that sits the way it should. If not, we'll have to remove it and redo it. Before we test it, we are going to check it using our multimeter, just to be sure. I'm just trying to cool it off a little bit. I'm not cleaning as yet. So our red probe on ground, and then our black probe. Let's be sure we don't have a short. Red probe on ground, and then our black probe. Let's check the first one. What do we have? 0.4. That's about what we're expecting to get. 0.46. That's about it. And then the other 0.3. That's fine. And then on the fuse line, 5.52. Okay, let's see on the other one. 5.52. Okay, just to be sure. Okay, yeah, that's fine. So it was lower the first time, obviously because of because of this guy here that was burnt out. Okay, so now let's see if it works. For testing purposes, you can use a MacBook Air DC jack. This is a MacBook Air DC jack. It's not a MacBook Air DC jack. The difference usually it's in the shape. So if you look at, see that? This is Air and this is a Pro. And this is for obviously for 2020 M1 down to the down to 2019. They use the same thing, the MacBook Pros. So 2021, it's going to be the 14 inches and the 16 inches, which uses a completely different type of so in testing, you can use the Air for the Pro for the Air, you can use, but obviously when it comes to fitting, it's not, cables are not the same, so you obviously struggle to fit this in place of this. Okay, that's it. We are just going to test. We already checked that we don't have a short, so now we're going to check. So most likely, sometimes the CD3217, this process that we followed, sometimes it works the very first time, and other times it doesn't, which means we'll have to remove it and then reinstall it. So let's check it out. So correspondingly, this here is going to correspond with that, and then that's going to correspond with the one at the back. And then another thing that I just want to So I don't know if I did this before. So this the the board number is going to be 820 dash 1987. Let's open that. 820 dash 1987. 820 dash 91987. Is that no? I think no. It's 01987. I think so. Yeah, 01987. So I just want to show you guys this. So in order for you to map the corresponding CD32, I'm just gonna orient it this way. So you see that I said the first one, which is at the top, corresponds with this, correct? And then the other side. But then how do you correspond? Because usually the way this works is this: if you connect a charger to any of this, either the one or the two, you will have voltage on the fuse, and then that way you probably get confused as to which one corresponds with which. The line that you can measure to tell you exactly which is corresponding, it's on this line here, which is the one that you have D3302 and D3370. Now you are not going to get, if I connect to, let's assume that this is let's say port A. If I connect my charger on port A, I'm not going to get, if I connect my charger on port B, I'm not going to get voltage here. You understand? But if I connect, it doesn't matter where I connect my charger, either port A or port B, the fuse you will have, provided the CD3217s or the CDs are working, you will have voltage on the fuse. Do you understand? And if you have voltage on the fuse by connecting your charger to either of the ports, you are not able to tell which of them corresponds with which. But if you but the but the voltage that you get on this line, yeah, on this line, that is to tell you that that is the line that corresponds with the CD3217. So you can either use this capacitor here, if you can get your way through to these two diodes, you can also do that. And then on the other side is the same thing. So on the other side, if I click on the other side, let's see, what is the diode? The diode should be here. So that's on the other side, that's the same thing. So you will only get voltage on this line. That is to help you confirm that this is, and this is across, this is the same thing across all of the CD32 or CD3215 or 17 configured logic boards. You want to go through, you want to see the PP, so where it says PP20 volt underscore USB C underscore XA VBOS. So that is where you can get your corresponding CD2 to the charging port. Okay, so let's go back. So we connect this DC jack, and we have an issue with that one. So let's connect it. Hopefully it doesn't blow up again. Yeah, we did try to. We did check for short before connecting power to it, so it should be good. So we have our multimeter set to voltage mode. We have our black probe to ground because we're measuring it for voltage, and then our red probe. Let's first check around the audios and see if we have anything. We have 3.3, that's fine. The other one, 1.58, that's fine. We should get 3.3, that is also fine. Let's see what is it that we have on our PP bus. If we get 12.6, that's good. It will mean that we have 20 volt here, which is exactly what we want. But if we get 12.3 or 0, then it probably means that we don't this is not properly installed, or maybe the other one is faulty. But let's see what is it that we have here. 12.3, so 12.3 and fluctuating. So 12.3, so if you have 12.3, that will mean that you have 5 volt on your PPDCN. So you see that we have 5 volt on PPDCN and it's fluctuating. So that can be good. Now let's see what is it that we have on the okay, it seems to be stable now. Let's see. So let's see what we have on the other side of the board. Let's see what we have on the second port. the same thing. So I'm just hoping that the revision, I hope they're not different, because this is an M1 board and B12. Otherwise, we can just grab one from an Intel board, because we know for sure that that CD3217 that we took off from the M1 board works. So we have 5 volt, and it's trying to boost, but it's not doing that. Okay, so what we're going to do is we're just going to get another one, get one from an Intel board, in case that it's not, in case that's why it's not working. So, although that cannot really be a thing, but let's just get another one here. Be very careful. Yeah, also that just looks like it wasn't properly installed. So what we are going to do is we are going to, yeah, just looks like it wasn't properly installed. Okay, well, so let's try to do a manual rebuild here. This is how I do my manual rebuilding. Mm, yeah, it works out, except it's just one bowl that I don't like that I'm gonna be taking off. But other than that, it works exactly how I want it to. Okay, that's it. So we're now going to remove some of the excess solder from here, and then we'll put it back. Hopefully it should work. Okay, so let's just confirm orientation. Orientation is, yeah, so pin 1 is the top there, that's your pin 1. See the red that symbolizes your pin 1, so we are going to orient it accordingly. So you see the dot, it's that dot is going to be that, it's going to be for the pin 1. It's not properly oriented. Okay, okay, so if it still doesn't work now, we are going to replace with another one. Trying to get it to dry a little, to cool down a little bit. Let's try again. Yeah, before we connect charger to it, let's just be sure that we don't have a short. It's in our dial mode, red probe on ground, and in our left probe. Let's see what we have here. 0.6, that's about 5. 0.8, that's about 5. That's about 5. And then the fuse, yeah, that's about 5. Okay. Let's see, what do we have now? Switch back to voltage mode. Red probe, what do we have? 3.4, that's fine. 1.58, that's fine. Okay, yeah, it's not properly installed. Yeah, board is not properly installed. The CD is not properly installed. Let's do this. And this time we're just gonna press on it. And be very careful because this area here, you don't want to. Okay, let's see. Let's hope we don't have a short on the line. Yeah. Okay, and then this. And now it's a dead short. Yeah, let's remove it. So I think while pressing it down, obviously bridged the balls underneath it. Can probably at the same time just replace it. Now get another one instead. Let's get another one. Okay, it's out. Trying to verify this. Give it a gentle tap. So hard. Okay, let's try to pull it off. So we plug charger to it. We are going to confirm that we don't have a short. We probe one ground and then our back row. It's about what you're expecting to have. It's about what you're expecting to have. It's about what you're expecting to have there. It's about what you're expecting to have. So now let's see what we have. Switch to voltage mode. Select the first line, 3.3. Okay, second, 1. Yeah, and then the third, 3.3. What do we have on PP bus? 12.33. And then it moves. Let's see again. 12.33. What happens? Does it move? Let's give it a whirl. And then yeah, okay, let's check the second one. It's trying to 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 go goes its way to 20 volt, which is supposed to give us 12.6. Let's see if that doesn't same thing. Okay, so since it's doing the same thing, what we are now going to do is let's get another ROM chip for the CD3217, which is this guy here. Let's get another board and swap the ROM chip before we check the other one. So I couldn't find the exact board. This is the 2019. I hope I think I did use the firmware before and it did work, but I'm just confirm. See if this is we have 20 volt at least on this one. Okay, so we have 20 volt on this. So I'm just going to show you guys. So that's 20 volt. So what we're going to do is we are going to transfer the firmware from here. That's the ROM chip for the CD3217s, because it's trying to, I say it's trying to do something, but it's not doing anything. So so basically the ROM chip here, we are going to reprogram it if that is the case. But I'm just going to try it across. But I'm taking a different ROM chip, but I think they kind of similar. Um, I'm not sure, but because I think I did use them across before and it worked. So I'm just gonna. So what I'm going to do is I'm going to transfer them over. Put this one here and the other one there, and then I'll try the other one to see if it works. So the reason why I'm doing this is if this works on this board, then it means the problem is not from the ROM chip. So, okay, so it's we tested this board before and then we were getting 20 volt. Let's test the board again with the RAM chip that we have. See what is it that. So if you get 20 volt on this, then it means a problem. The RAM chip that we got from there, it's actually working. 5 volt, and is it still on 5 volt? Yeah, 5 volt. Okay, so it's 5 volt. Because it can also be a compatibility issue, so we're not sure as yet. Let's check here. Okay, so that's it. So the power, so alongside the CD3017 burning out, the RAM chip is also burned out. I don't know if you guys saw that. So that's 20 volt. Initially we are getting 5 volt. So what we did was we basically had to take the ROM chip from here. So the ROM chip I'm talking about, this guy here, which is U2890. So there are two ways you can do this. You can do a direct transplant, which is what we've just done now. I think this is a 2019 board. What is a 2020 board? They're not directly the same thing, but in the past I have used the RAM chip for 2019. I believe I had done a swap between them, and then it did work. So we can choose to leave it as it is, or we can choose to reprogram its own So another thing that if you saw that one of the reasons why I moved on to the ROM chip was this. So um, you could see that the behavior that we were getting. I'm going to show you the behavior here now. So the what's the yeah. So now this behavior. So the charging ports. So so let me show you guys that. So that is 5 volt, and it's gonna try to boost. So it tries to boost, and then but then it's not able to, and then it goes back. Now when I checked this second, so if I when I check this second port, so if it is that one of the port is doing that and the other port is just flat 5 volt, then I'm gonna kind of consider the other port. But in this case, both ports were giving me the exact same behavior, which would mean that the problem is not it's not the CD3217 per se, but rather something within but outside the CD3217. And then I had to then again look at the ROM chip. So I swapped the ROM chip over, as you guys can see. And then also, which also meant that the one that we took from here, the first one we took from the M1 is actually still fine. So we are going to put that back. So with this one, we are just going to check to see that it actually, so this will need to be reprogrammed. But let's see if that works. Remember, we said we are also going to swap out the DC jack. So I'm just going to get another DC jack quickly. This is so 20, so an A1990. The DC jacks are the same. Okay, so we are going to test before we clean the board. We're only going to connect those cables that we need for the testing. Okay, project's connected. We have trackpad feedback. Expecting to see something on the screen. We have trackpad feedback. We have a chime, and that's an Apple logo. So yeah, this is a working device. Just a quick summary of what we did, and so after we opened up the device, we realized that there was a physical bound. There was a bound out CD3217. We replaced it with one from an M1 board, MacBook Air. That didn't work. We thought, okay, maybe what we got is somehow not compatible. We had to take another one from an Intel board, which is 2020 as well. This is an Intel 2020 board, MacBook Air. We took the same CD3217 revision, and then we installed it, and it still didn't work. We got a similar, during the course of installations, there were times when the CD was not properly installed, And the first time we thought it's no problem. It's also we had to remove it to reinstall it for the second time, but that didn't fix it because we had crumbled balls underneath the chip. So we had to take it off to redo it. So after we did it for a couple of times, we realized that we are getting the same behavior, which is the CD3217 is trying to boost to 20 volt, but that's not taking place. And the behavior it's exactly the same across the CD3217, which suggests that the issue it's not on the CD3217s, but something outside CD3217. So we decided to go around to the ROM chip. This is the ROM chip here. So this board is a 2019 board, not a 2020 board. The board itself is a 2020 board, but then the ROM chip are interchangeably compatible. So we had to take a ROM chip from a 2019 board, put on it, and then we put a 2019, put its own ROM chip here. So when we put the ROM chip here, the behavior we're getting on the board was then transferred here. We're getting the same behavior. So what we wanted to do is, if the ROM chip had worked here, then we will know the problem is not the ROM chip, and then we have to then move forward. But then the ROM chip didn't work, but the ROM chip that we took from here to the board, it worked. And then as you guys can see, now, there are two ways you can do this in terms of ROM chips. You can do a direct transplant, just like what we've done just now, or you can reprogram. The ROM chip, the old one. And if you have to reprogram it, then it doesn't have to be the particular one. You can take from any board, the same chip, and then reprogram it. Just what needs to be the same thing is the files on it, and then you can install it, and then it should be good to go. So that's about it, guys. I will see you guys. So we're going to finalize it and then have it cleaned up, and then yeah, see you guys in the next one. Thank you.